You have heard fascinating stories where science is working at the frontier of knowledge of what we know today and what we think we will know in the coming century. Science is not isolated from society, and I want to use my 15 minutes to look at what are the challenges that arise on the interface between science and society. What you have heard now depends, first of all, on the place, the attitudes, the kind of appreciation that science has in society. If we look around the world today, we see science is not evenly distributed. There are leading countries, there are leading hotspots, places of universities that you want to go to, where you know the working conditions are excellent, and there are other places that look more or less like a scientific desert. And this is the result partly of history, of course, everything is the result partly of history, but partly it has to do with the appreciation that a society gives to science. What you have seen is funding that has been received, and we have universities, we have research institutions, we have the prospects for future careers. All this must be funded from somewhere. And the kind of science you have been listening to needs public funding. Let's be clear about that. Private funding is always welcome, but the kind of frontier research comes with public funds. Now, way back in the 30s, there was an American by the name of Abram Flexner, and he wrote a manifesto with the title, The Usefulness of Useless Knowledge. And this manifesto was a plea to set up an institute where the kind of science would be funded where you do not know as yet where it will lead to. And a couple of years later, he was successful in getting the funding he needed. In this case, being in the US, it came from private money, but it led to setting up the Institute of Advanced Study in Princeton. And in the beginning, the first people to be employed were mathematicians. There were also historians, and there were a few others. And it was dedicated to the usefulness of useless knowledge. Alan Turing was there for a couple of years. John von Neumann built the first computers in the institute. And in fact, it became the place in which what you have been talking about, computational science, was born. And of course, the time being the entry of also the US into the Second World War, it meant it made tremendous contributions, useful contributions to the war effort at that time. And this is one of the first challenges that we need to remind politicians, but also the general public, of the usefulness of seemingly useless knowledge. Politicians, as we know, they want applications, they want deliverables, they want to have results already before you have begun your research. And in some ways, this is okay. This is what politicians have to insist on because it's taxpayers' money, etc., etc. Nevertheless, we have to make a special effort, and it's a continuous effort, I can assure you, of convincing them that unless investment goes into this kind of, call it fundamental science, call it frontier research, whatever the name, where you do not yet know what the outcome will be, is essential for the 21st century to continue. Now, what it also shows, this journey into the unknown, is that it is a kind of research that is inherently uncertain. You do not know where it will lead you. You do not know the outcome. What we know from history, and Terry has brought this up and it has been confirmed many times, we know it takes about 50 years from the first breakthrough to a broad range of applications We also know this from medication and drugs. It takes about 20 years to come up with something useful on the market and so on. So there are these lead times, but there is uncertainty. You do not know where you actually will get, what you will get, and when you will get it. So this is one of the largest challenges vis-a-vis the funders that I see. We also know there have been some moving testimonies to this. For instance, François Jacob, the French Nobel laureate, he spoke about day science and night science. Day science is the glorious side of science. You know, the glossy brochures that every university puts out to show what is being done. You have the product fairs, etc. But then there is night science. And night science comes with, again, a lot of uncertainty. It comes with some frustration. You set up an experiment, it does not work. You have to go back, ask yourself, you know, what did I make wrong? You start again. And these are the two sides of the same coin. Just as day and night belong together, so is these two sides of science. And we take far too little effort in letting the public, the society, we have to convince of the usefulness of useless knowledge, the kind of inherent, uncertain research that we want to pursue. We have to let them see a glimpse of night science as well. We have to let them in to see the process of research and not only the finished results, to let them partake in the fascination, this wonderful excitement that comes when you are onto something. You don't know, it may not materialize. You start again, but you have this feeling you are onto something. Now, you have also heard the importance of technology. And indeed, technology is very important, but it's not exactly the same as science, nor is it the same as innovation. And very often we mix up these concepts. Technology is much older than science, but historians of technology and also historians of the economy tell us that somewhere in the second half of the 19th century, there was a switch to what is called science-based technology. In other words, there was a new interaction that came about at that time between science and technology. Science-based technology means that the technologies we use are science-based. They are an embodiment of scientific knowledge in a sense. But at the same time, we can also see how important it is, the kind of questions that are opened up by using a new technology, feedback into science. They allow you to pose new kind of questions that you could never have posed, knowing you have no tool in order to answer them. So this very close interaction is important. Now, to come back to the way how politicians, society, expect from what we now call often the techno-sciences, seen from the outside. We don't see how exactly technology and science feed into each other, but we see something is going on where they are entangled. Now here, this leads to the kind of technologies that society is familiar with. Think of it as the end of a process, and you are the generation that grew up with having a certain kind of technology in your pocket, and you can see how your children are already discovering what you can do with this technology much earlier than you were able to do it, and so it goes on and on. But it also leads to something that Brian alluded to, namely the way how this will change the way how our economy and our society actually works. Again, going back to the 30s of the last century, there was a student club in Madrid, and a student club in Madrid at that time made a point of inviting some of the most illustrious speakers from science around the world. They had invited Albert Einstein, but they also invited an economist by the name of Keynes. And Keynes And this is remarkable, 1930, these were the years of the Depression, both in the US and in Europe. He chose an unexpected topic. He chose to speak about the future for our grandchildren. So he made a big leap forward, and he said, let's look at the year 2030, 100 years from now, and see what the world will look like. By and large, his predictions, they were limited to what he called the mature economies. So basically, he looked only at the US and Europe. By and large, his predictions were correct. People will be better off, etc., etc. But then he made a prediction that leaves us a bit stunned today, because he said in the year 2030, we will on average work 3 hours per day. Think about it. We have not arrived at 2030 yet, but with automation, Industry 4.0, etc., proceeding very rapidly, you see that we will have a problem. For him, it was, by the way, a moral problem. What will people actually do with their time? While for us, it's a political problem, it's an economic problem, and it is an unresolved problem. And therefore, I think it has to be taken into account when we think at this, what happens at the interface between science and society. What people see are the technologies that change their life. And if you are out of work because everything becomes automated, this is not a very good situation to get the kind of support from society that you want and that you need. So this means also that something needs to be done on that part of the interface, listening to what are people worried about. What is their perception of what science and technology will bring to them? Because at the end of the day, they ask the question, what are you doing for us, for me and my job, my family, etc.? Now, a lot of research has been done on risk and risk perception, because scientists, of course, have noticed that not everything that science or technology produces is welcomed with open arms, and people have a different risk perception. I have been struck throughout the ease and also the willingness to embrace uncertainty that science demonstrates. Science thrives on the cusp of uncertainty. These are the rare breakthrough moments when you are between what is already known, what is not yet known. It's exciting, and science thrives on this cusp of uncertainty. In society, and we are part of society, we like to have certainties. Sometimes there's even a craving for certainty. We want to know what's going to happen. And then there is also this misconception. We turn to science and we ask them, tell us what will happen, without realizing that very seldom scientists can say a clear yes or no. They will tell you yes under the conditions of. No, and they're right. This is the only correct answer. No under the condition of. But this is not what politicians want to hear, and this is not what most of us as citizens want to hear. We want to have this certainty. So there is, again, something to be done, a challenge in how we convey what uncertainty actually means. What are the risks? We also know most people worry about the wrong things. And there have been, again, many, many studies comparing the actual occurrence of events that are to be avoided with the fears and the risk perception people have. And what people don't worry about are the risks that you don't see, that you're not familiar with, namely the systemic risks. And since Brian spoke about moving into large systems and understanding them better with the thresholds, the tipping points, etc., these are things you don't see. They build up. You don't see them coming. Then all of a sudden they are here and they hit you. So again, this is something that needs to be conveyed to society that these systemic risks exist. Now I want to end with something, a new opening of science that I see happening, that has already started at the beginning of this century. In fact, there are always antecedents. So the astronomers have always had a lot of support from amateurs who were fascinated by what astronomy did. Botanists in the 19th century could rely on amateurs. Amateurs means lover, by the way. So the lovers of science, it's an old tradition. But in this century, what we have seen is called citizen science. It's a kind of movement that comes partly from the fact, and this is something we have to remember also, we are the most educated societies on Earth today that ever existed. In terms of formal education that people get, in terms of access to knowledge, to information that they have. And this opens up new doors. And citizen science uses these open doors, but an open door is always open towards both sides. So on the one hand, scientists are welcoming the open door. They have set up ways of using, inviting, accompanying lay people who want to participate in the process of research. This has happened some time ago in biomedicine, where patient groups have shown to have much more knowledge because they live with their relatives, with their family members who have certain conditions, and they have shared their knowledge with the doctors and people from the life sciences. But we can also see people who are computer savvy, who work on their laptops, for instance, to help a crowdsourcing problem, how a certain protein is folding, etc. In the environmental area, we have lots of people who are using apps and other technologies that are widely available today to help monitor and so on. So there is an ongoing open door here, a movement of citizen science that I think can, and it's not fully developed as yet, and we know too little what are the motivations of people, how can we sustain them, etc. But nevertheless, I think it is one way of tackling what I see to be the greatest challenge. Science is the best invention that humanity has made to bring the future with all its enormous potential into the present. But it needs society and a close interaction with society to shape it. Thank you.